Hi geometry students, it's Miss Graham and we are going to be continuing lesson 25-4, looking at angles formed by tangents and secants. So we are going to go ahead and start at the bottom of page 364 looking at number 5. Question number 5 says, in his design, Chris decided to use 3 spotlights evenly spaced around the reflection pool. Draw a sketch of an overhead view of Chris's design. What fraction of the pool's edge is not illuminated by the spotlight, and what fraction of the pool's edge is illuminated by 2 or more of the spotlights? So let's first start off drawing the reflection pool. So we're going to go ahead and draw a circle that represents it. There we go. Now before we put the 3 spotlights in, let's figure out how we want to position each one. So we want to remember that each of our spotlights can be a certain distance from our pool's edge to illuminate a specific part about it. Now keep in mind that's going to be illuminating what our other side is. So this could technically keep going and we would be illuminating this side of our pool. So we have to be a little strategic about where we want to place each of these lights. Let's say I wanted to place my light a certain distance away over here. And let's say it was able to illuminate this whole side. So we were able to illuminating this whole side. So we can see it matches kind of right up to here, all the way looking at the right side, all the way to here. Now, let's say we also wanted to do a spotlight from the other side, right? Because we have one, maybe we could try doing one a little opposite. Space it out a little bit back here. And let's say that light illuminates over here. So we can see that it picks up kind of where the last light left off and goes around the whole side and ends exactly at the same spot. So looking at this, technically if we position 2 lights kind of in a nice way, we actually don't have to have a 3rd light. We could just have 2 lights to illuminate our entire edge. So we're going to say 2 lights can illuminate the entire pool. All right, we can see every part of its edge. So it says, what fraction of the pool's edge is not illuminated by the spotlights? Well, right now we're going to say 0% or, 0 out of whatever our fraction is. It says, what fraction of the pool's edge is illuminated by 2 or more of the spotlights? We can see that it's going to be 100% of what we're looking at. Let's go ahead and go to the next page, 365, and keep going up at the top. Even though he did not use them in his design, Chris investigated 2 additional situations in which the spotlight is located outside of the circle. We can see that is shown in our figure below here. It says in the figure, AT, which is a ray, and AR, another ray, intersect the circle in 2 points. So what name can be given for these 2 segments? So go ahead and write down what you think that should be. So hopefully you realize since this goes through our circle, it pierces it, goes in and out and touches it twice. I hope you remember our vocab word that these both are secants. The other segment does the exact same. Part B says the points P, T, R, and Q divide the circle into 4 arcs. So which of the arcs lie in the interior of angle A and which lie on the exterior of that angle? So go ahead and see if you can figure out which of those arcs are on the interior of angle A and which lie on the exterior. So the ones that are on the interior should be arc PQ and arc TR. And I'm going to go ahead and highlight those as well. So PQ and TR. And then those on the exterior should be arc. Let's try again. Should be arc PT. And it should be arc QR. And let's go ahead and highlight those in the matching colors as well. Remember, when you're labeling your arcs, you should also put the symbol of the arc right above it. Cool. So now let's look at question C. It says, which of these arcs are going to be intercepted by angle A? So keep in mind when we say intercepted, right? That means angle A is going to have those arcs inside of it. So really what we're looking at is our same interior arcs from before. Arc PQ and arc TR. So now looking below at part D, it says if the variables A, B, C, D, as we can kind of see represented above here, if they represent the measures of each of the 4 arcs, then we know A plus B plus C plus D, what must it equal? That's right, it should be 360 degrees, since that makes our full circle. Let's keep going down to part number 7. So number 7 says inscribed angles are formed when RT is drawn. In terms of ABCD, we want to figure out the measure of angle 3 and the measure of angle 4. So keep in mind we might need to add a couple extra pieces for our knowledge. So let's look at the measure of angle 3. Well, we see right here we have angle 3. So we want to visualize, okay, that angle opens up and matches which arc. So if we follow the lines, we can see that it starts all the way from here and goes to there. So I'm going to go ahead and highlight that for us to visualize. Now, we kind of want to see, using our pieces of information, how that would yield. Well, remember, with our inscribed angles, it's going to be the measure of half of our arc length. So if we added the arc pieces together of B plus C and divided that by 2, we would get the measure of angle 3. So we can fill in the blank B plus C divided by 2. I want you to pause the video and see if you can figure out what the measure of angle 4 would be. And then once you have it, go ahead and resume the video. All right, so since we're looking at the measure of angle 4, that means we want to see where angle 4 lines up. We can kind of see it lines up here, but we want to go ahead and kind of extend these lines and see which arc it matches up with. If you look at it, you can kind of see the arc matches up here, a little overlap with our other arc, but you can see that we're adding B and D together, and we know the angle measure will be half of that. So I can say B plus D divided by 2. So using that definition of inscribed angles, as well as the arc that they intercept. Awesome. Let's go ahead and head to the next page. Let's start looking at problem number 8. So we can see we're going to be using this visual above to work through number 8. So 8A says, let X represent the measure of angle A. We want to have X plus the measure of angle 3 plus the measure of angle 4, and we want to figure out what degrees that equals. So let's kind of visualize and see what we're working with. So remember, we do have a triangle forming here. And we can see that all of those angles, since we're labeling this X, angle X, all of those add to, well, 180 since it's a triangle. So we're going to go ahead and write down that all of those add to 180 degrees. Now it wants us to substitute the expressions that we found in our previous problem, problem number 7, on the page before. And we want to see what we can do to rewrite this equation. So we're going to substitute these expressions we found for 3 and 4, those angle measures. So we're going to take the spot of the measure of angle 3 and the measure of angle 4 and just rewrite it. So remember, what we got for the measure of angle 3 before was b plus c divided by 2. And what we got for the measure of angle 4 was b plus d divided by 2. So we're going to substitute those in there and kind of rewrite our equation to see what we get. So we have x plus b plus c divided by 2 plus b plus d divided by 2 equals 180. And to kind of help us figure out how to get rid of these denominators, since they're not really that fun, is we're going to multiply both sides by 2. So remember, when we multiply both sides by 2, we're going to end up distributing that 2 to each piece here. Something kind of funny happens, right? When we distribute the 2 the first time, we'll get 2x. But when I distribute the 2 the second and third time, it actually cancels with our denominator. So what I'm left with is just b plus c plus d plus b. And then don't forget, over here we have to do 180 times 2, so that gives us 360 degrees. So look at this. Nice, not too bad. Now maybe let's combine the b's together, so that way we'll get 2x plus 2b plus c plus d equals 360 degrees. Now, I just went through the simplest that I could make it. That's how I knew I had to keep going throughout here. We're going to build off of this and start looking at part C. So for part C, it says refer to the equation in item 6D and solve this equation for C plus D. Well, here's what we're really going to do. We're going to take kind of what we have before and build off of it and see what we can get. So go ahead and actually, we're going to cross out the second sentence, those directions. Let's just take the equation that we have from the previous page, 6D. So we came up with that on 6D. We actually did this previously. So it was just A plus B plus C plus D, and we filled in that it equaled 360 degrees. So now what it wants us to do is to take our responses that we have in parts B and C and bring them together for D. So it says use your responses in B and C, right, to find an expression for X in terms of A and B. So let's start looking at and kind of comparing what we came up with. Maybe there's a way, since both of them are equal to 360, that I could set their other expressions equal to each other, right? A little bit of substitution, yeah. Okay, so let's do that. Let's take our first equation of 2x plus 2b plus c plus d, and we're going to set it equal to a plus b plus c plus d. So we can see on both sides, they both have a C and a C. So if I subtracted the C's, they would actually cancel each other out. So I'm just going to cross them out. We can do the same with the D's. So look at this. Now we're going to be left with 2x plus 2b equals a plus b. Again, let's start to isolate 2 by itself, right? So we're going to go ahead and subtract 2b, so we're isolating 2x. So I subtract 2b. And then what I'm going to be left with after that is 2x equals a minus b. And last but not least, we divide by 2 to get x by itself. I'm running out of a little bit of space, so I'm just going to go ahead and write down a minus b divided by 2 is what we get when we solve for x. So that is our ending result currently. Now part E, again, is building off of this, and it wants us to complete the theorem. It says the measure of an angle formed by two secants. Ooh, okay, so we're going to have to kind of zoom out and look at this picture above. So our goal is to kind of find what x is, right? That's what we're going to relate it to. So what we're going to see is the measure of this angle formed by two secants. You know, it's drawn to a circle from a point outside the circle. We can see that. We're going to see this angle is actually equal to a minus b divided by 2. So let's see what that references in our picture. Let's see what a is. So a is kind of this outer arc right there. So we're taking the outer arc, that big arc, and subtracting this kind of smaller arc. Both are intercepted by angle A, and then really we're dividing it by 2. We're taking half of that. So that's what we're going to fill in right here. So let's zoom back in. Again, look at this. So we know this is going to be equal to 1/2 times our big arc minus our little arc. And both of those are the intercepted arcs of angle A. Now let's go to the next page and just look at the example below that kind of puts this idea into practice. So let's look at example A, where it says in circle C below, where we have the measure of angle PAQ. So we have this is 40 degrees. We have the measure of arc PQ is 140, so I could label that on there, 140 degrees. And then it says AP and AQ are tangents, so we want to find the measure of arc PRQ, so this whole guy out here. So keep in mind that formula that we used, right? That 1/2 times our big arc minus our little arc is going to give us the measure of this angle, measure of angle PAQ. So that's kind of the formula that they set up here. It's going to be the measure of this angle will equal this big arc minus this arc times 1/2, or we could say divided by 2. Now we know what the measure of this angle is. We know it's 40 degrees, so we can fill that in. And in our formula, we actually know what the little arc is. That's 140 degrees. But our goal is to find what the measure of the big arc is, PRQ. So that's what we're going to solve for. So to start off by solving this equation, finding out the measure of this arc is, we're going to multiply both sides by 2 to get rid of this half. So that's how I got 80, and that's how I got the half to cancel. And then last but not least, I'm going to add 140 to each side. So that way I get the measure of our big arc is 220 degrees. Now you could always double check to see if I can input it into here, and I get, you know, when I subtract it, divide it by 1/2, I should get the measure of angle PAQ. So that's how we're going to apply this idea. Do not worry, I'm going to give you an opportunity to add to your word wall at the end of this lesson. Before we do that, we're going to do a little bit of practice. So let's go ahead, go down below. We're going to look at the try these A. So here we can see that we have our picture as before, where we have our two secants intersecting our circle. So I'm actually only going to require you to do part A, because parts B, C, and D, they are different problems that are based off of the same picture. So we only have to work through part A. If you're someone who wants to do parts B and C on your own, B, C, and D on your own, I will give you the results and answers and show you the work to those just in case, but I'm only going to have us be required to do part A. So looking at part A, we can visualize and see that we want to find out what X is, right? That angle measurement, if we know what A is, so if we know what our big arc is, and if we know what our little arc is. So let's go ahead for part A. We know that our big arc measurement is 125 degrees. We know our little arc measurement is 35 degrees. And for part A, I'm going to do it up here, and I'm going to use that formula, right? So we have kind of that angle measurement is going to equal 1/2 of our big arc minus our little arc. So we're using X to find out what that angle is. So X equals 1/2 times 125 minus 35 degrees. So we have X equals 1/2 times 90 degrees. So X is actually going to equal 45 degrees. So again, if you want to pause the video right here and try any, B, C, or D, go ahead. I'll give you a little bit of time to practice maybe one or two of those. Definitely, if you want to challenge, do part D because it incorporates solving equations. But go ahead and pause the video and I'll share the results with you shortly. All right, so I actually redrew the pictures for each so I could label them, and I have B, C, and D below, so go ahead and check your answers. Pause the video when you're ready to move on. All right, so we're actually going to go ahead and add onto our word wall. So again, I know we kind of already drew secant lines before, but I wanted to add this on again. We can see secant lines are slices. They are lines that kind of slice through our circles. So what we're going to do is we're going to add in, when two secant lines intersect, the measure of the angle formed is our angle equals 1/2 times our big arc minus our little arc. So we can draw the picture over here. You can kind of disregard this line there. That was just a little error, but you can see I have two secant lines. I have my big arc of 135 degrees. I have my little arc of 25 degrees. And let's say I want to figure out what that angle is. I can use my formula to find that. And I see that that angle is 55 degrees. Remember, we don't just have to look for the angle. We could actually be looking for the big arc or the little arc within that and just have to know how to manipulate our equation. All right, so for Ms. Graham's class, your homework for tonight is to start the Lesson 25 practice worksheet. So that's not going to be due until Monday's class period. It's about 17 problems over 5 pages, so it's good for you to get a head start tonight on it. You will also have during class time tomorrow to work on it, to ask me any questions over it, as well as the weekend to work on it. So go ahead and pull up the Lesson 25 practice, and I will see you all tomorrow. Happy mathing!